All right, so we're going to be just going through this worksheet. We're going to use those formulas there just to help us out. And what's highlighted is based on what you're trying to find and how you can find that. So we see that the pH is 10.03. We're looking for the concentration of the hydrogen ions here. We know that that has to be 10 to the negative pH value, and we know that the pH value is 10.3. So all we have to do is plug that in, 10 to the negative 10.3, and we get about 5.01 times 10 to the negative 11. And concentration, of course, is in the units of molarity. Over here, we're looking for the pH, and then from that we can figure out whether it's acidic, basic, or neutral. So you're given the concentration of H plus here, which means that we can calculate the pH because that P just means negative log of whatever that concentration is. Notice there's only one hydrogen ion that'll be formed in solution here, so we don't have to worry about multiplying that concentration value by anything. So we just plug it right on in, negative log of, we'll go 2.1. Second, that capital E means times 10 to the, and then negative 12. And then we get about 11.68 or so. And this value right here, because it's above 7, we know that this is a base or a basic solution. Calculate the pOH if the OH concentration is that. So we have just the OH concentration. The pOH is going to be the negative log of the OH concentration. In this case, 5.9 times 10 to the negative 1. And we go through negative log of 5.9 times 10 to the negative 1, and we get 0.23. Now that's pOH, and we can't figure out acidic, basic, or neutral based on pOH. We have to figure out the pH. So I'm going to figure out the pH by taking 14 and subtracting my pOH. And that's going to give us, to be specific, about 13.77. And this, so we have the pOH there. This is going to tell us, since it's above 7, that this is, again, a base, not an acid. All right, what is the pH of a 0.033 molar KOH solution? Now notice I'm looking for pH, but I give you KOH, which is a base because it has the OH ion. So what we're going to end up having to do is take that 0.033 concentration, find the pOH first. So that's going to be the negative log of that 0.033 concentration there. And I only have one OH ion that's going to be formed in solution, so I don't have to multiply that concentration by anything. And I get negative log of 0.033, which is 1.48. And then to find the pH, again, I know that, right, pH plus pOH equals 14. So what I can do is I can just take 14 and subtract 1.48 from that. 14 minus 1.48 gives us pH of 12.52. All right. So again, just paying attention to pH versus pOH, and then what you're given. Are you given a base, or are you given an acid that's based off of the formula? You get OH. An acid, of course, will have an H in the front for the hydrogen ion. What's the pH of an aqueous solution with a hydroxide ion? So that's OH. Concentration of this. So again, we're looking for pH, but we're given OH concentration, so we find the pOH first. Negative log of 1.8 times 10 to the negative third, negative log of 1.8 times second e, negative 3, and that's going to give us a pOH value of 2.74. And then for the pH, again, pH is going to be 14 minus that value. So we end up with a pH value of 14 minus 2.74. And that gives us 11.26 as our pH value. A lot of bases, a lot of bases. What's the pH of an aqueous solution with a hydroxide ion concentration? Again, hydroxide ion is an OH minus. So again, give you the concentration of the OH, looking for pH. So we need to find pOH first. Negative log of 1.2 times 10 to the negative 6. That gives us negative log of 1.2 second, 10 to the negative 6, and that gives us 5.92 as the pOH, and to find pH, we just take that value and subtract it. So 5.92, 14 minus 5.92 gives us a pH of 8.08. So still basic, weak base, not strong. What's the hydrogen ion concentration of a solution with pH? So now I give you the pH, and I'm looking for the hydrogen ion concentration, which is the H plus, right? So in order to find the H plus concentration, you take the pH value, and again, it's 10 to the negative pH value, which is negative 8.25. 10 to the negative 8.25 is going to give us a concentration of 5.62 times 10 to the negative 9th, and concentration is molarity. What's the pH of a 0.235 molar BaOH2 solution? Now, we did this one in class, but I'm going to do it again because you notice that there's two hydroxide ions that are a part of this base, right? So what we're going to have to do before we do anything is take the concentration there that's provided and multiply it by 2, since there's actually two hydroxides that are going to be formed when this is dissolved in solution. So what the pH is, well, again, pH and pOH are different. I find pOH based on having a base like this. So I first need to figure out what the pOH is. Now again, the concentration of the OH is going to be 2 times 0.235, since 2 hydroxides are going to be found for every 1 barium in this. So I take that and I get, I believe, 0.47 if memory serves. So 2 times 0.235 gives me up 0.47. So from that, I'm able to take my pOH, negative log of 0.47, and that gets me, let's see, negative log of 0.47, 0.33-ish. And then, of course, I'm asking you for the pH, so I take 14 minus 0.33, and that's going to give me 13.67. So just to show you that, 2 decimal places is fine with this. And there's my pH value based on that base and that concentration. So the only wrinkle is, because that's going to be 2 hydroxide ions, basically 2 moles of hydroxide ions in this thing, I need to make sure I multiply it by that amount for the concentration. Determine the OH concentration in ions in an aqueous solution where we have a pH of this. Well, again, we can't just do what we did up in number 7, because that would give us the hydrogen concentration, since this is a pH. So what we're going to do is we're going to take this pH and we're actually going to find the pOH, which is, again, just taking 14 minus that. So that's 5.22. 14 minus 5.22 gives us 8.78. So using the pOH, that's how I'm going to be able to figure out the OH concentration there. So I take, again, if I'm trying to find the concentration, I have to take 10 to the negative pOH in this case. Before, we took the negative pH when we were finding the H concentration. So this is going to be 10 to the negative 8.78 since we're talking about OH, and that's going to give me 10 to the negative 8.78 gives me a concentration of 1.66 times 10 to the negative 9th, and that is molarity. All right. So far, so good, hopefully. Again, if you have questions, always reach out. What's the hydroxide ion concentration with a hydrogen ion concentration? So now we're talking H pluses that I give you, but we need the OH minuses. So there's going to be a couple of steps here. Because I have the hydrogen ion concentration, I can find the pH. Right, so we can do this in 2 steps. So let's find the pH first. pH is the negative log of the concentration, and I'm given that the concentration of hydrogen ions is as follows. So what I can do is I can take negative log of that value, 2.7 times, let's try that again. Negative log times, 2.7 times 10 to the negative 2nd, and I get a pH value of 1.57 rounded. And from this, what I can do is I can find the pOH value, right, which is just 14 minus that. So once I find the pOH, I can then work backwards like I did above, and then just figure out the concentration of the hydroxide ions there. There is another way to do this by using the concentrations themselves with times 10 to the, or 10 times negative 14th, but I feel like this is a little bit nicer. So 14 minus 1.57 gives us a pOH of 12.43, and the last step, in order to find that concentration of the OH, I can take 10 to the negative pOH that we just found. And that's going to give us 10 to the negative 12.43. And that'll give us a concentration for hydroxide of 3.72 times 10 to the negative 13. And that is molarity. All right, calculate the pH of a solution that is 0.14 molar HCl. Again, we're looking to see how many ions. In this case, we're talking about an acid because it has a hydrogen ion in the front, and there's only one, so we don't have to do any multiplier there. So all we have to do is take that concentration, just plug it right into our pH equation, 0.147, and then that would be 0.147. That gives us a pH value of 0.83. This is certainly very, very, very acidic. All right. Let's see here. So we can fill out this table, and it's kind of just like a nice little chart. Now remember, you can only figure out if it's an acid or a base using pH only, right? You can only use pH. You can't use pOH there because it's a pH scale, not a pOH scale, right? So going through this, let's kind of work backwards here. So the pH of this would just be the negative log of that. So we'll do negative log of 1 times 10 to the negative 3, and that's going to give us a pH of 3, which means there's a pOH of 11, right? 14 minus 3 is 11. And then we get the OH concentration by taking 10 to the negative 11th because it's 10 to the negative pOH. So we end up with, and I won't do that right now to save room. There we go. 10 to the negative 11. That's, of course, going to give us 1 times 10 to the negative 11. And these are really nice numbers just because we're dealing with whole numbers. You'll see as we kind of go that it will vary. And is this an acid or a base? Well, this is an acid because that pH value is 3, which is less than 7. So over here, we're given the concentration of OH, so why not find POH, which is just the negative log of that. 1 times 10 to the negative 8, and we get 8, which means that this is going to be 6, right? And then we're going to figure out, okay, well, based off of that, 10 to the negative 6 would give me that H concentration, because, again, to find the concentration, it'd be 10 to the negative pH value, since we're talking about the H, or the hydrogen ion concentration. So 10 to the negative 6 gives us 1 times 10 to the negative 6 molar. Is this an acid or a base? Well, it's an acid. And why do I know? Because that value there is 6. Now, because of that, this is going to be exactly the same because the pH value is 6. So if I were to kind of work backwards here, you're going to end up with all the same values because the negative log of, just like we did before, 10 to the negative 6 is 1 times 10 to the negative 6 molar. Again, 14 minus 6 is 8, and then, of course, we're going to get the same thing over here. So 2 of the same one, just starting with a different value, you can get to the same spot. Again, 8 and 5 are, 6 and 8 are close to neutral, but we, for the sake of simplicity, are just going to say that if it ain't 7, it ain't neutral, all right? But it's definitely a very weak acid with a pH of 6. Let's go POH2, which means that we have a pH of 12. Super acid there. And then you can kind of work backwards whichever way you want, right? This is 10 to the negative POH for the OH concentration. This is 10 to the negative pH for the H concentration. And we have both of those values there. So let's just do that really quick. And that's going to end up being, of course, to the negative 12, but you've probably picked up on that already. 1 times 10 to the negative 12 molar, and this will be 1 times 10 to the negative 2nd molar. Again, really nice numbers. Of course, this is, again, an acid based off of pH. Oh, I am so sorry. I'm going a little too quick. That would, of course, be a base. That would be a base. What am I talking about? This would be a base. And again, it's all based on that pH value there. All right. So now we're going to get into some numbers that aren't as nice, which is fine because we do everything the same way. So the concentration of H is provided. So let's find the pH by doing the negative log of that. 2.3 times 10 to the negative, 10 to the negative 10. And we get a pH of 9.64. That's going to mean that the POH is 14 minus that, 9.64, and that's about 4.36 here. And we're going to do 10 to the negative 4.36 to get the OH concentration, which is 4.37 times 10 to the negative 5th molar. And then this, of course, will be a base based off of that pH value there, above 7. Over here, we're given the concentration of OH. Let's find the POH, negative log of that concentration value, which is 8.5 times 10 to the negative 1. That gives us a 0.71. And 14 minus 0.071 is going to give us about a pH value of 13.93. All right. So again, I'm doing some very rough rounding here, but those are going to equal somewhere close to our value of, our value of 14 there. So and this would be 0.71, my bad. All right, there we go. And then, of course, we go 10 to the negative 13.93, and that gives us our concentration of the hydrogen ions there, times 10 to the negative 14th molar. And this is a super base. All right, and again, kind of just thinking about this, to the negative 14th is a super small number, which tells you that there are not a lot of these hydrogen ions in there, which means that this is just going to naturally be much more basic because there are significantly more OH ions that are a part of this solution. Let's go only a couple more. We can do it. Negative log of 6.9 times 10 to the negative 4th. That gives us a pH value of 3.16. And then we can get our pOH value, 14 minus 3.16. That gives us 10.84. And then we go 10 to the negative 10.84 to get the concentration of hydroxide ions, which is 1.45 or so, times 10 to the negative 11th. And this is going to be an acid because that pH value is less than 7. And last but not least, pOH. So I'm going to find, or the concentration of H I'm given, so I'm going to find the pOH first. 5.1 times 10 to the negative 11. That gives me 10.29. And then 14 minus 10.29 to get the pH, 3.71. And last but not least, 10 to the negative 3.71 will give me the concentration of those hydrogen ions that make up that pH. 1.95 times 10 to the negative 4th molar. And last but not least, this is certainly an acid. All right, so hopefully this helps out a lot. And again, if you have any questions, always feel free to let me know. All right.